Describe the operation of a bipolar junction transistor. A bipolar junction transistor is a semiconductor device that uses two p-n junctions. Transistors are the base component in most semiconductor circuits and serve one of two primary functions: to operate as an electronic switch and to amplify a signal. Bell Laboratories invented the first transistor in 1947, and it has since led to the creation of more complex semiconductor devices, such as integrated circuits and microprocessors. Transistors are smaller, use less energy, and operate faster than the vacuum tube and mechanical relay devices that preceded them. Shown is a comparison of the three devices. There are two types of bipolar junction transistors: NPN transistor and PNP transistor. Most bipolar transistors are NPN because they are easier and more economical to manufacture. An NPN transistor uses a layer of p-type semiconductor material between two layers of n-type semiconductor material. It has two depletion regions, one at each junction of the p-type and n-type material. Attached to each of the three layers is a terminal. The center terminal is the base, and the outer terminals are the emitter and collector. Shown is the schematic symbol for an NPN transistor. Notice that the emitter has an arrow pointing outward. In a bipolar transistor, the arrow is always located on the emitter side of the symbol and points toward the N-type layer. It is understood that the collector is made of the same material as the emitter and that the base is the opposite type. A second type of transistor, PNP, is sometimes used. A PNP transistor is identical to an NPN transistor, except that it has the N-type material sandwiched between the two P-type layers. A PNP transistor has an N-type base and P-type collector and emitter. Shown is the schematic symbol for a PNP transistor. Notice that the emitter has an arrow pointing inward. In a bipolar transistor, the arrow is always located on the emitter side of the symbol and points toward the N-type layer. The basic concept of a transistor's operation is that a small input current flowing between the emitter and base controls the larger output current flowing between the emitter and collector. To operate, the transistor requires that a forward bias voltage be applied to the base emitter junction and a reverse bias voltage applied to the collector base junction. This means a positive voltage is applied to the base emitter junction and a positive voltage is applied to the collector base junction. PNP transistors operate exactly like NPN transistors, except that the polarity of the bias voltages is reversed. PNP transistors are used when the circuit requires current flow in the opposite direction to NPN transistors. A transistor is able to function as a switch or as an amplifier because of the way in which the base current changes with the voltage applied to the base. A base emitter junction characteristic curve is shown. The vertical axis is base current, I sub B, and the horizontal axis is the base emitter voltage, V sub BE. Cutoff region. The base emitter PN junction operates like a diode. Until the applied voltage reaches approximately 0.6 volt. Cutoff region. The base emitter PN junction operates like a diode. Until the applied voltage reaches approximately 0.6 volt, there is little to no current flow. This is known as the cutoff region because the transistor is effectively turned off. The small amount of current flowing is insignificant. V sub BE exceeded. Once V sub BE exceeds approximately 0.5 to 0.6 volt DC, the base current begins to flow. Linear region. As the base voltage increases further, the base current changes proportionally. This is known as the linear or active region. As V sub BE is increased further, the base current continues to increase. If the voltage applied to the base is increased too far, the base emitter PN junction will be damaged. Shown is a graph of the collector current I sub C versus the base current I sub B. The base current has a direct effect on the collector current in the transistor. During cutoff, the transistor is off, so there is no collector current or base current. When enough voltage is applied to the base to cause base current to flow in the linear region, the collector current increases proportionally with the base current. In the saturation region, the base current is still increasing, but the maximum amount of collector current is already flowing in the transistor, so the collector current does not increase any further. The transistor operates as an amplifier by applying bias voltages that cause the transistor to operate within its linear region. To operate as a switch, a high or low voltage is applied to the base. The transistor turns fully on when a high voltage is applied to the base, driving the transistor into saturation, and turns fully off when no voltage is applied to the base. Until V sub BE reaches approximately 0.6 volt, little to no base current flows into the transistor. Once V sub BE exceeds approximately 0.6 volt, the base current increases proportionally with V sub BE. A very small base current results in a much larger collector current. Once the I sub C reaches its maximum value, it does not increase even if I sub B continues to increase.